Hi, folks. It is still February 21st, and I'm still on the subject of gravity. This one is, I want to go back to the black holes as a topic and expand on that. In this case, it's my notion of um, black holes, uh, the gravity, essentially, that is surrounding a black hole, relaxing. And so eventually the black hole itself will disappear. What I wanted to do is expand that to include the entire universe. Essentially, the Big Bang is an enormous black hole explosion, if you will, as a comparison. And that kind of leads to the possibility that we're living on within an event horizon of some kind. Not really what I want to talk about just now. I, at the introduction of all that energy at the Big Bang, our universe became first, but it disturbed gravity and made it much, much more complex. And one way of thinking about it is wind blowing across the surface of water, like on an ocean, and the more intense the wind, the more complex the surface becomes. And I think that's not a bad analogy for what happens with gravity. So in this case, here's my prop again, my tinfoil prop. Uh, you can think of gravity before the introduction of energy as being flat, and then the energy making it much more complex. All right, so we wind up with something like this. So the plane of our existence, gravity itself, is all still there, but the energy has made it so complex that it's hard to distinguish one particular spot from another. And we have then a situation where we have collections of um, intense amounts of energy in specific areas. So we have galaxies now, and uh, stars and planets. So there was no, at the very moment of the Big Bang, there was no differentiation. It was just all energy, essentially at some fraction of a moment. It was all essentially one frequency, and then it started differentiating as entropy took over, and our universe and the complexity of the universe, although itself is an extremely complex process, could maybe be thought of as kind of a reverse Seneca curve in the sense that you have this incredibly steep initial spike of energy and complexity, and then a long, 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 long taper of entropy taking over and um, energy dropping in frequency. So from high frequencies or high states or hot, very intense hot energy states to infrared and below uh, over, you know, billions and billions and billions of years. But coupled with that, what I think happens then is that, just like I said with the black hole, um, the plane, the gravitic plane, is relaxing. Not evenly, obviously, because we have stars and planets that are intensely more condensed areas of both energy and gravity. But overall, we have a situation where the plane is relaxing again and essentially going flat over millennia. This would may help explain the discovery that our universe is expanding. Uh, there was debate about that, but it seems now the consensus is that the universe is expanding. Okay, that's fine. Maybe it's because gravity is relaxing. The um, the thing I'm wondering though has to do with dark matter. Some of you might know where I'm leading with this. So we have our plane of existence, our gravity, relaxing. But is it going to, and at some point, what I'm thinking is at some point, um, our plane of existence relaxes to a point where wherever the energy came from in the Big Bang uh, is allowed back in again. So we're going to have another Big Bang at some point, billions and billions of years again from now, as the pressure, if you will, or the complexity of gravity lowers to a point where that energy can come in again. Hopefully I'm explaining that adequately enough. What I'm wondering though is it going to get perfectly flat again? So what I'm suggesting here is the energy in the universe and gravity are irreversibly linked together. And if there is a certain amount of energy in an area, then you're going to have a more complex and denser, if you will, area of gravity. So if you have the field of gravity, or the plane of existence of gravity, relaxing, it may not relax entirely so that the pressure, if you will, reduces enough to allow another Big Bang to occur. But what that may mean is that there is going to be a remnant amount of energy from our Big Bang, if you will, left over, still in existence in our universe. But with this new Big Bang that may come in, we get a whole new universe, essentially. So, is that what dark matter is? Is dark matter remnant energy from previous Big Bangs? You see, because I'm suggesting that the universe doesn't relax completely before another Big Bang occurs, it's a bit bigger, if you will. There's space in here now. I know. And so there's space in here for remnant energy from a previous Big Bang to exist while new energy, new intensely high energy is injected back into the universe and it gets complex again. But The remnant energy is still there. And maybe the, I'm really going out on an extreme limb here. Maybe because of the remnant energy, the universe gets bigger, or not as much energy is allowed in the next time, so that the process of relaxation may speed up over time because we don't have as much energy in the universe with the second Big Bang or the third Big Bang and the fourth. And as that progresses, if you follow the my very slim logic here, the amount of energy with each Big Bang becomes less because there's more remnant energy left over, and so the process speeds up. So the next cycle, or the next 10 cycles of the Big Bang, by the time you get to the 10th one, it's relaxing a lot faster because there just isn't as much energy, new high energy in the universe to overcome. A wild idea, but I kind of like it. More soon.